Imagine a man, right, just walking down a dusty road in 600 BCE India, and he's obsessively picking up these discarded, dirty grains of rice.
Yeah, to anyone walking by, he probably looks completely out of his mind.
Exactly. I mean, why is he scavenging something that even a beggar would just walk right past?
Right.
But inside his head, this man is, he's quietly writing the foundational laws of physics.
That's wild.
He is literally defining the atom, and he's beating Sir Isaac Newton to the punch by, over 2,000 years.
Which totally shatters the conventional timeline we're all taught in school, right?
Yeah, completely.
Like, we assume the building blocks of physics were uncovered in, I don't know, 19th century Europe by guys looking through glass lenses and measuring weights on brass scale.
Right, guys in coats in laboratories.
Exactly. But the stack of sources we are diving into today, they pull us way back into ancient history to examine a mind that arrived at the mechanics of the universe through, honestly, just pure, staggering logical deduction.
Yeah, so today we're reconstructing the biography of an ancient Indian philosopher named Acharya Kanada. And the mission for this deep dive is to figure out how someone living between the 6th and 2nd century BCE mapped out an atomic theory and the laws of motion without ever stepping foot inside a modern laboratory.
A tall order.
It is. Okay, let's unpack this because it is absolutely incredible to think about where these ideas actually originated for you all listening. But I'm struggling to picture his environment. Like, was he just sitting isolated in some desert having random thoughts, or was there an intellectual culture supporting this kind of breakthrough?
Well, he definitely wasn't operating in a vacuum. To really grasp the weight of his theory, we first have to ground ourselves in his biography.
Okay, yeah, let's start there.
So Kanada was born in Prabhas Kshetra, which is near modern-day Dwaraka in the Indian state of Gujarat.
Got it.
He was born to a philosopher named Ulka. And fun fact, his given name was actually originally Kashyapa.
Kashyapa. Okay. And the sources highlight that this specific region is steeped in thousands of years of Indus Valley history, right? We're talking about an area close to ancient cities like Bilavira and Lothal.
Yeah, exactly, which is a crucial piece of the puzzle here.
How so?
Well, those ancient Indus Valley cities were renowned for really highly sophisticated urban planning, complex maritime trade networks, and incredibly precise standardized weights and measures.
Oh, interesting. So the concept of measurement was already deeply ingrained.
Exactly. Kashyapa was the inheritor of a civilization that had already been thinking in terms of, standardized reducible units for centuries.
So he was kind of hardwired to look at the massive, chaotic world and seek out its underlying order.
Spot on. Which brings us back to that legendary story from his childhood, the dusty road and the rice.
Right, the race story.
So he's accompanying his father on a pilgrimage to a town called Prayaga. And as they walk, young Kashyapa starts obsessively collecting these individual discarded grains of rice.
I can just imagine his dad getting so annoyed.
Oh, yeah. So his father finally stops him and demands to know what on earth he's doing. And Kashyapa's response is it's a masterclass in foundational logic.
He argues a chain of causality, doesn't he?
He does. He says, look, a single grain of rice seems worthless on its own, but gather enough of them and it contributes to a meal.
Right.
Meals sustain families. Families make up the entirety of mankind. Therefore, he reasons that single microscopic grain is as fundamentally important as all the riches in the world.
That is profound for a kid. And because of this, hyper-focused worldview, he earned the moniker Kanada, which in Sanskrit translates literally to atom eater.
Atom eater, yeah. It's a great name.
Such a cool nickname.
Yeah.
And there's even another legend that he got the name because he would sit at his meals, breaking his food down, dividing a piece in his hands over and over again until it physically couldn't be divided anymore.
Just crumbling into dust.
Yeah, and he called that ultimate limit paramanu, para meaning beyond, and anu meaning atom or particle.
What's fascinating here is that this wasn't just some quirky obsessive habit, right? This was the birth of an atomistic approach to physics.
Right.
He realized that the division of matter just cannot go on infinitely.
Yeah, I buy the analogy of zooming in on a digital photograph on your phone.
Yep.
You see a landscape, but if you keep pinching and zooming in, eventually the smooth image breaks down into rigid blocks.
Oh, that's a perfect way to look at it.
Right. Zoom in as far as the software allows, and you hit a single solid square of color, the irreducible pixel.
Yep.
Kanada was basically searching for the universe's pixel. But wait, why couldn't the universe just keep zooming in forever? What stopped him from assuming infinite division?
That is exactly where we see his genius at work. He used what we call invariance arguments.
Okay.
Canada argued that if matter is infinitely divisible, you run into a massive philosophical and mathematical paradox.
Mhm.
Think about a giant mountain and a tiny mustard seed.
Okay, I'm picturing them. Giant mountain, tiny seed.
Right. So if matter can be divided infinitely, then both the mountain and the mustard seed are composed of an infinite number of parts.
Wait, really? Both of them?
Yes, because in the realm of infinity, mathematical sizes lose their classical meaning. A mountain and a seed would mathematically be constructed of the same infinite number of building blocks.
Oh, wow. Which would imply they are equal in their fundamental constitution. That's absurd.
Exactly. It's totally absurd. So to avoid this paradox, Canada proved logically that there absolutely must be a finite stopping point, a base unit, the paramanu.
That is a staggering feat of human reasoning, honestly, to just think your way out of that paradox.
It really is.
And this obsession with the smallest details, it kind of consumed his entire lifestyle, too. Like the Jain texts in our sources describe his extreme asceticism.
Yeah, he didn't really have a normal social life.
No, they referred to him as Saduluka, with Uluka meaning owl. He lived like an owl, spending his entire day in isolated study and meditation and only eating once a night.
Right. And in that nocturnal isolation, he founded an entire school of philosophy known as the Vaisheshika school, and he authored its primary text, the Vaisheshika Sutra.
So he was busy during those night shifts.
Very busy. His ambition scaled up rapidly.
Yeah.
He didn't just want to find the smallest particle. He set out to categorize the infinitely diverse universe into a manageable system of reality.
Yeah, he sorted everything that exists into 6 padarthas, or predicables, basically 6 properties that can be named and known.
Right.
We have substance, quality, action, generality, particularity, and inherence. But, I mean, just reading that list feels a bit hollow. How did these categories actually interact to create reality?
Well, let's apply it to a physical object, something simple. Imagine a clay pot holding water.
Okay, a clay pot.
In Canada's system, the clay itself is the substance.
Yeah.
The reddish color of the baked clay, that's its quality.
Got it.
The act of the pot containing the water is the action. The fact that it shares characteristics with all other pots in the world, that's its generality.
Okay, I'm following.
The unique scratch on its side that makes it your specific pot, that's its particularity. And the fact that the red color cannot be separated from the baked clay-like it exists within it is inherence.
Ah, I see. So he built a kind of metaphysical filing cabinet where every single phenomenon in the universe had a specific logical place.
Exactly. Everything fits into the cabinet.
That clarifies the mechanics beautifully, but as I was reading the sources, I hit a massive roadblock regarding his ultimate motivation.
The spiritual aspect, yeah.
Yeah. The texts explicitly state that the fundamental goal of Canada's teaching in the Vaisheshika school was the liberation of the soul. It was a spiritual pursuit.
Right.
So how does sorting a clay pot into 6 mechanical categories lead to spiritual enlightenment? It feels like reading a physics textbook to achieve nirvana.
That is such a common reaction. And it highlights a profound difference between ancient Indian philosophy and modern Western science. Today, we build a firewall between physics and spirituality. They're separate departments. But for Canada, there was no firewall.
No.
He defined dharma, which translates roughly to religion, ethics, or duty, as exactly that which brings about both material progress and the ultimate good.
So understanding the physical world isn't a distraction from the spiritual world, it's the prerequisite.
Precisely. In his system, reality is divided into the soul and the not soul.
The not soul. I like that.
Yeah, and Canada's logic dictates that you can only truly understand the soul by rigorously, flawlessly defining everything that is not the soul.
Oh, wow.
Mastering the physical mechanics of the universe was the very path to ultimate liberation, because it stripped away the illusions of the material world.
And by categorizing that not soul, he had to rigorously define its smallest substance. Which brings us back to the paramanu, the atom.
Right back to the atom.
And his specific descriptions are where the ancient philosophy starts sounding eerily like modern chemistry. Oh, completely. He proposed these atoms are indestructible and eternal. They cannot be created or destroyed, only rearranged.
Sounds familiar.
Very. He stated they are invisible to the naked eye. He even went so far as to theorize 4 different types of atoms that make up physical substances, 2 types with mass and 2 types without.
And he also insisted they had to be spherical, using the term paramandala. His reasoning was that an ultimate, indivisible particle must be perfectly uniform, the same in all dimensions.
Ecological sense.
Yeah, and then he mapped out how they interact. He theorized biatomic molecules called divinuca and triatomic molecules called trianuca.
And what did he identify as the catalyst for these atoms combining and rearranging?
Heat. He noted that visible changes in everyday objects, like an earthen pot turning black in a kiln, or a piece of fruit ripening and changing color in the sun, those were the result of invisible atoms rearranging themselves due to thermal application.
The thermal application, exactly. To use a modern equivalent, when you boil water for your morning coffee today, you are essentially observing Canada's exact theory of thermal atomic rearrangement in real time.
That's a great example.
Think of it like a game of billiards. The thermal energy of the heat is the cue ball, breaking a tightly packed triangle of atomic billiard balls, forcing them to scatter and find an entirely new resting arrangement.
That is a phenomenal way to visualize it. The application of energy forces a structural change at the invisible level, which then manifests as a physical change at the visible level.
Here's where it gets really interesting, though. Let's play devil's advocate for a second.
Okay, let's do it.
Because our sources highlight a massive debate here. Institutions like the Maharaja Sayajirao University have issued statements linking sages like Canada directly to modern nuclear technology.
Right, which is a bold claim.
Very bold. And then we have the critique from the Wire Science. They argue it is controversial, even outrageous, to equate Canada with someone like John Dalton in 1808.
Yeah, they push back hard on that.
Dalton used empirical testing, quantitative measurement, and actual scales. Canada was just thinking really hard. Without empirical math, isn't Canada just doing sophisticated poetry? Like, can we really call it science?
It's a fair point, and this raises an important question about the definition of science itself. The Wire Science makes a valid modern critique. Dalton's theory carried the explanatory burden of modern science because it could be mathematically falsified in a lab.
Right, you can't falsify a thought experiment in the same way.
Exactly. Canada couldn't falsify his claims with a particle accelerator. However, to dismiss his work as mere poetry completely ignores the rigorous framework of ancient Indian logic known as Nyaya.
Okay, so how does Nyaya differ from just guessing?
Well, Nyaya relies heavily on inference, or anumana. It operates on the principle of universal concomitance.
Universal concomitance. Break that down for me.
Sure. A classic example is if you see smoke rising above hill, you infer there is a fire even if you cannot see the actual flames.
Because where there's smoke, there's fire.
Right. The logical proof is ironclad based on observable causality.
Yeah.
Canada applied this to the microscopic world. We cannot see atoms, but we observe the effects of their combinations, like the fruit ripening or the pot blackening.
Oh, I see.
Therefore, the invisible cause must logically exist. It wasn't poetry, it was a systematic, geometric proof of reality based on strict rules of inference. It's a different form of rigorous deduction, sure, but it is deeply rigorous.
Okay, yeah, I accept the rigor. He logically proved the existence of these spherical interacting atoms. But here is the missing link for me.
What's that?
Static pixels don't make a universe. A bunch of atoms just sitting there is just a frozen photograph. How did Canada account for time, change, and movement?
He realized that exact problem.
Yeah.
Physics and motion are the absolute engine of Canada's worldview. He stated that the concepts of time and space do not exist independently as empty containers.
Wait, really?
Yeah, they actually arise out of the motion of atoms. Without atomic motion, time and space as we experience them wouldn't even exist.
Which honestly sounds dangerously close to modern relativity, but we will stick to classical mechanics for now.
Probably a good idea.
Because the sources draw a direct side-by-side comparison between Canada's ancient sutras and Sir Isaac Newton's 3 laws of motion, which were published in the Principia in 1687.
Big three.
Yeah. Now, we all know Newton's first law of inertia: an object at rest stays at rest unless acted upon by an outside force. What blew my mind was reading Canada's first proposition on motion.
Let's hear it.
He wrote, "From motion, new motion is not known."
Wow.
He is describing inertia using entirely different philosophical language 2 millennia earlier. He explicitly argued that motion does not spontaneously generate itself without an external cause, and he specifically names gravity as one of those causes. By the way, objects fall or stay still. They don't just move on their own.
The parallels only get stronger, too. We know Newton's second law relates force, mass, and acceleration, right?
Yeah.
Showing how an applied force dictates subsequent momentum.
Right, F equals ma.
Exactly. Well, Canada's equivalent sutra translates to the initial pressure leads to the arrow's motion, momentum, and subsequent motion.
The arrow.
Yeah, he used the analogy of drawing a bow. The impressed force on the string transfers directly into the momentum of the arrow, dictating its proportional change in motion.
That's incredible. And then there's the most famous one, Newton's third law: for every action, there is an equal and opposite reaction.
Right.
Canada wrote in Sutra 1.1.14, action, or karya, is opposed by reaction, or karman. He explicitly laid out the fundamental symmetry of the universe. Action is opposed by reaction.
If we connect this to the bigger picture, we do have to acknowledge the boundaries, right? Canada didn't formulate these laws using calculus.
Sure.
He didn't provide mathematical equations to calculate the exact trajectory of a cannonball the way Newton did. But the conceptual architecture, the persistence of motion, the absolute necessity of external causation, and the conservation of momentum, it is undeniably present and perfectly aligned with classical mechanics.
So, what does this all mean? When you look at the biographical journey of Acharya Kanada, you see a mind that just entirely transcended the limitations of its era.
Absolutely.
From a boy picking up a single grain of rice on a dusty road to an ascetic philosopher meditating through the night, he constructed a flawless logical framework for reality.
It really proves that ancient Indian philosophy preserved profound structural truths about the physical world long before the modern scientific revolution gave us the empirical tools to verify them in a laboratory.
Yeah.
The power of human observation, when combined with disciplined, rigorous logic, is just timeless.
It makes you wonder how many other ancient texts are sitting out there holding the answers to questions we haven't even figured out how to ask yet.
Actually, to that very point, I want to leave you with a final thought to ponder. There is a small detail in our sources that bridges this ancient past directly to our scientific future.
Oh.
Yeah, it involves Werner Heisenberg.
The pioneer of quantum mechanics. The physicist who proved with the uncertainty principle that at the subatomic level, the universe is inherently unpredictable.
The very same. Heisenberg actually once noted in his writings that learning about Indian philosophy made these seemingly crazy ideas of modern quantum physics suddenly make much more sense to him.
Wait, really?
Yeah, the philosophical frameworks of the East, which embraced interconnectedness, the illusion of solid matter, and complex metaphysical realities, they actually provided a context for the bizarre, counterintuitive quantum realm that traditional Western Newtonian physics deeply struggled with.
Wow. So he found comfort for the quantum paradoxes in the ancient texts.
He did. So I challenge you to consider this. If the disciplined, logical mind of a philosopher from 600 BCE could predict the indivisible atom and the classical laws of motion with such stunning accuracy using only inference, what other ancient philosophical abstractions might hold the key to understanding the unsolved quantum mysteries of our future?
Honestly, if we ever figure out the math for quantum gravity, we might just find out Canada already wrote a sutra about it.
I wouldn't be surprised.
We started this deep dive thinking about a digital photograph, zooming in until we found the irreducible pixel. It turns out Canada didn't just find the pixel, he figured out the fundamental code that makes it move.